Hello everyone and welcome back to another edition of Indexer Office Hours. Today is the 25th of March and ladies and gentlemen, we are at the 200 mark. We are here. This is IOH number 200. I cannot believe we are at episode 200. It's been, what is it? 2 and a bit years, maybe 3, that we've been doing this. I think closer to 3 actually. And every week we've been here consistently shipping out these episodes, these calls for you guys, and it's incredible to see that we are at number 200. Thank you to each and every one of you who show up every single day. Oh, every single day, sorry. Every single week for IOH. We do this for you guys, and it's great to see all these familiar faces, and it's lovely to see that there's a bustling community here. So thank you, everyone. For anyone who is new to Index Office Hours, this is the town square where ecosystem participants come together and discuss the most important and relevant topics for indexers. You know what I'm going to say, guys? This is a conversation, and we do love participation. So if anyone wants to drop the meme, feel free to. And if you'd like to get involved in today's conversation, feel free to via voice or mic. If you're having any challenges with your microphone, do let me know and I'll get that sorted for you. As a reminder, this is a session that's going to be recorded and posted onto public channels like YouTube. So if you are concerned about privacy, please bear that in mind. And with that, let's get into today's agenda. Okay, who's ready for another edition of 𝗨𝗂𝗂𝗪 screws up people's names and can't pronounce them? Vince is excited. Okay, alrighty. Okay, so let's see if we have any. Oh boy, I don't think you can screw this one up. Don't be so sure, Juan. Never underestimate my abilities. I am competent at screwing people's names up. 𝗨𝗂𝗂𝗪, hold my beer. Hyperbole Juan. Yeah, have faith. Okay, yeah. Have faith in my abilities. I mean, I don't have faith in my abilities, but let's see. Okay. Holger. His name is Holger, and his surname is Ahrens? Holger? No, I said H. Holger. Oh, okay. How to pronounce? Oh, thank you, dude. This is great. Aryans. Okay. According to the YouTube video that was just posted, it's Aryans. Holger Aryans. Okay. Is that how people pronounce his name? Did I get that right? I wonder where it's from. That's actually an interesting name. I would assume perhaps maybe Scandinavian or Nordic. It gives me that vibe, but I could be totally wrong. The G is silent. Augur. Oh, I think he goes by Henry Adams. Interesting. Okay. Oh, okay. Well, wait, are you trolling, Josh, or is that okay? You're joking. I was like, that's Josh is trolling. Okay. I don't even know what trolling is anymore. Yeah. Okay, so it sounds like the G is silent, so it's Olger. Olger Aryans. Olger Aryans. Okay. Lol, I made that up. Okay, oh my god, you guys are the biggest trolls. Even at episode 200, this never stops. This is funny. Special trolling for 200, exactly. Yeah, that's hilarious. Okay, so he is the chairman and CEO of 𝗨𝗀𝗀𝗀𝗀. And that's a global payment infrastructure provider, and they enable people to convert fiat into crypto through their solution, and they integrate with various exchanges and platforms that you will know, like Binance, OKX, and MetaMask, and they handle the regulatory compliance KYC stuff there. Oh, he's German. Okay, so he grew up in Germany, and his father was a car dealer, and he used to work there on his school holidays, which was interesting. studied business in Netherlands, has an entrepreneurial journey, moved to Australia, discovered Bitcoin in 2013, and has had a very interesting and fruitful career in Web3 and is currently building Baxter. So if you're interested in that episode, do check out the link that Juan has posted. Okay, enough with opening remarks. I'm going to hand over to Anna for our regularly scheduled Repo Watch section.
Thank you, Abel, and hello everyone again. Right, so today on Repo Watch, starting as always with execution layer clients, we have had a new release of 𝗟𝗀𝗀. This is the much awaited release 3.0.0, which introduces a lot of breaking changes, and those include default setting for checkpoint sync and improvements to historical transaction execution. It is crucial for all operators to note that a resync is required, and several new parameters have been added to optimize data storage and access. This is an important change requiring attention and resync, and we're also working on a launchpad chart for 𝗟𝗀𝗀 3 specifically. Then on Get, we have had, and yes, thank you for mentioning, Matthew, 𝗟𝗀𝗀 2 will be decommissioned May 1st. So you have a month and a week to move to 𝗟𝗀𝗀 3. And 𝗟𝗀𝗀 3 is awesome with snaps, says Vince. That's awesome. We will share more details, so please do, whoever has tried it, let us know if you come across anything we should be aware, and so on. Alright, so next release is from Get. This is 1.15.6. This introduces major performance upgrades in Get log filtering through filter maps, improving search efficiency, and a new version of 𝗟𝗂𝗪𝗀 that streamlines the creation of Go bindings for Solidity contracts, plus some other RPC method updates that include some breaking changes that require careful integration. This is an important update, but not immediately critical. Then we have two new releases from Rat. I think we actually agreed we call it Read, but it's 1.3.3. So this release adds full support for Hoodie testnet, enabling users to utilize it with chain Hoodie configuration, plus additional features and configurations improvements that have been included. This is an important update, but low immediate criticality. And then we have version 1.3.4, which includes vital fixes for the upcoming ops stack Isthmus hard fork. So here users are advised to update, but the urgency is low as changes are marked as low priority. Let us know if anyone has is going to sync with the Hoodie testnet. Then we have a new release from Nethermind. This is version 1.31.6. This release includes a crucial fix for a memory leak in the trace transaction method, which could cause Node to require restarts under heavy load. Additionally, the gas limit on the host key testnet has been increased to 60 million, providing more opportunities for extensive testing. So this is a critical memory leak fix that requires immediate upgrade for Nethermind. Then Avalanche has a new release. This is 1.13.0, which introduces critical updates, including dynamic EVM gas limit effective on April 8th, which necessitates immediate upgrades for all Fortuna supporting mainnet nodes. Immediate upgrade, so for the network operability if you're using Avalanche. We also have Firehouse Ethereum new release, so 2.11.3, which optimizes tier 1 and 2 processing with improved error handling, some retry controls, and performance enhancements. Important for reliability, but not immediately critical. Then still on execution layer clients, we also have a Heimdall release. This is 1.2.1, which introduces Matic CLI Docker scripts for improved deployment and updates to this version, enhancing functionality without critical changes. This is just a release that you want to take advantage of, but it's not critical change. We appreciate the 𝗨𝗪𝗀𝗃𝗀𝗀 Ethereum release that contains Matthew complains about a bunch of things, fixes. Much appreciated. On the consensus layer client, we have a new release from Prism. This is 5.3.2, which again enables support for Hoodie testnet, plus introducing a feature to treat certain blocks as invalid, which is essential for network stability. This is again testnet update critical, but mainnet recommended. Teku also a new release 25.3.0, which introduces Hoodie testnet changes, also important for those operations. Nimbus same 25.3.1 Hoodie testnet changes, plus other improvements here. Then from Lodestar, we have two new releases, so version 1.28.0, which introduce critical fixes and optimizations, including support for Hoodie. And version 1.28.1, which is a minor hotfix addressing a configuration issue for validator clients on the Hoodie network. Non-critical fix for those specific users. Then finally, on the graph stack, we have a new release of indexer service. This is the TypeScript version. So this release is 0.21.1, which is a patch that introduces support for several new chains, including Zora mode, rootstock, Polygon, ZK-AVM, and ZK-Sync era, and enhancing integration options for operators. This is a essential release for those looking to expand their ecosystem, but it doesn't necessarily require immediate action. And this is all we have for this week. That's quite a lot, but yeah, over to you, Juan. Thank you.
Thanks, Anna. Okay, in contrast with Anna's update, Protocol Watch is going to be short. There's no new updates for forum governance, research, or network subgraphs. There are some updates to the contract repository, mainly anything that has to do with the Horizon, particularly the Horizon latest round of audits. There's a lot of fixes that stemmed from those audits, as well as some changes to integration test and some post-audit changes that are non-solidity. So yeah, that's pretty much it for Protocol Watch. I'm going to be handing over to Abel now.
Amazing. Thank you both for your sections there. I don't see Slim here. I did message him before to no avail. He did not respond to me. So I'm assuming, and I don't see Kate here as well. So I'm assuming there isn't any update today in the way of upgrade indexer. They're both out of office. Okay. Anyone else? I mean, maybe Vince, are you gonna? Because I wasn't aware of anyone else maybe taking. So I want to create some space in case there was an update. So anyone from 𝗏𝗏𝗏𝗀 or 𝗏𝗏𝗏𝗀 want to chime in on that? If not, then we can always move on. Okay, I'm assuming, yeah, unless otherwise, I see Mickey's typing update on the, yeah, every week they come, well, no, every week they come on and just share a bit about the latest on the upgrade indexer. And they just requested that I give them a couple of minutes after Protocol Watch to do that. Enabling, yeah, exactly, correct, yeah. But they seem to be both out of office, and I haven't heard from them. So, anyways, let's move on. Lots of creation activity in the past few days. Should we expect more short term? Is that question? I see Mickey's typing. Is that question for 𝗏𝗏𝗏𝗏𝗏? I'm not sure. Let me check with Ali. Okay, cool. All right, well, I'll take the opportunity to move on then. So we have the good fortune of having Samuel from 𝗨𝗀𝗄𝗧, who is here with us today. And he is going to talk about a very important topic, which is the rollout for dips. Talking about the initial batch of supported chains, how much you as indexers can expect to get paid for accepting dips agreements per chain, as well as 𝗨𝗨𝗄𝗧's plans for gateway charging developers, that kind of stuff. So without further ado, Moonboy, feel free to take the mic.
Awesome. Okay. So the plan is to cover how much indexers can earn for accepting indexing agreements, and the first part of the presentation will focus on that. It'll be 11 slides. My screen should be live now, so feel free to tune in. And then following from there, we're going to look at how we plan to evolve the indexer payment pricing model over time. There'll just be a quick slide on that. We'll look at the initial batch of supported networks, and this is kind of a caveat there. It's non-binding. We could change this over time, but I think we're relatively confident with this. And then moving on from there, we'll look at how much our gateway will initially charge subgraph developers for subgraph indexing services, and how we plan to adjust this over time. And then we'll just have 10 minutes for questions towards the end, so if we have time. Cool. Okay, so yeah, let's get to the first section. So first of all, one of the things that we're considering is what are an indexer's typical overheads before they can start to sync a subgraph. So one of the larger components of it is the cost of running and maintaining either an archive node or a firehose node. That might not always be the case, because some of the smaller scale indexers may not necessarily have their own archive or firehose node. Perhaps they either pay to rent someone else's, or perhaps they receive it free from a friend or something like that. But probably for the much larger scale indexers, then this is something that they're going to have to consider. So in this area, you have the cost of storage, which is one of the largest components when running these. But you also have the cost of compute memory. If you're running at home, then it could be the cost of electric and internet costs, or also in co-location, you can have those costs associated as well. And then you also need to factor your operational costs. So that kind of covers the archive node component. But then you also have the cost of running and maintaining graph node, which has the same costs associated at different scales, but kind of like the same components, really. So yeah, one of the questions that we were asking is, like, how many subgraphs should indexers be looking at amortizing their costs over? And I have a note here that in the current network, indexers' primary source of revenue is paid via issuance. So indexers typically compete to index for subgraphs that have a high curation signal to allocated stake ratio. But when it comes to dips, indexers can start thinking about earning new types of income and be incentivized to allocate to subgraphs that may not have any curation signal in the future. So in this dips world, where indexers can earn yield from these types of subgraphs, that's where I want to focus this question, that question underlined here. So what is a typical number of subgraphs that indexers allocate to, and how difficult is it to scale? For example, how difficult is it to scale from 50 subgraphs to indexing 250 subgraphs? And then another question that I have is, how many subgraphs are there on each network, and what percentage of subgraphs would data consumers pay to be indexed if the upgrade indexer was not providing free subgraph indexing services? So yeah, I guess we'll get into the next slides. Before we do that, there is something to keep in mind, and that is that when we're balancing this as a kind of like an equation, we're thinking about the overheads that indexers are incurring for providing their suite of services, and some room for profit, and balancing that against the costs that subgraph developers have to pay to the gateway to have their subgraphs indexed. And the goal here for DIPs, as it relates to subgraph indexing agreements, is to have a competitive fair market economy that enables indexers to compete for indexing agreements, where both indexers and subgraph developers can benefit from healthy competition. And we believe that we can price subgraph indexing services highly competitively, and we're planning future improvements to the pricing models that can further cement this competitive advantage. So here we're looking at a monthly cost comparison of network attached cloud storage volumes that various providers can supply storage for. So as an example, AWS at the top here, they're charging $102.4 per terabyte per month. And then obviously you can read the rest of the chart. But something to note here is 𝗨𝗀𝗃𝗃 is one of the cheaper providers of network attached storage. And they're able to supply that sort of between this $40 and $45 range per terabyte per month. But this in general, all these prices are particularly high. And the reason why is because with cloud storage volumes, they're typically triple replicated, so you have your data stored in 3 different zones, possibly even on 3 different continents, and then you're paying for that replication and the availability that comes with that. And if your infrastructure does go down, then your data doesn't go down with your own infrastructure because it's backed up. So here we're looking at what different providers are able to price their services at in terms of prices. So we have a cost per gigabyte of RAM per terabyte of storage. This is in general, if it's not in yellow, then it's locally attached storage. If it's in yellow, then it's a network attached storage. So it tends to be higher. And then we also have a price per core or per thread, per logical core. And then we have a ratio. So for example, with host key, you can see that they charge 32 cents per gigabyte of RAM, $10.13 per terabyte of storage, and $5.35 per thread on the AMD side. And we previously reached out to various indexers and asked indexers how much they're paying for storage, and it was great to see some indexers get back to us. And for example, some indexers, I've just have a note here that they're running on 𝗨𝗃𝗃, for example. This is indexer number 1. That they said that their costs are kind of outlined here. And then we have some other costs as well. So one of the things with indexers, if they are purchasing their own equipment upfront, obviously they don't have a monthly cost that's associated with a one-time purchase. So there was a few assumptions that we kind of made to convert a one-time purchase to a monthly cost. And one of the ways that we did that is we said that an indexer that has this one-time purchase will look to amortize it over the lifetime of the hardware purchase itself. And we assumed that lifetime to be 48 months, a 5% interest, and with a 35% hardware resale value at the end of the period. So, for example, a 12.8 terabyte drive that costs $2,400 in total would have a monthly cost of $295 plus the cost of electric. So, I guess the next question is, how much will Edge and Nodes Gateway pay for indexing services, for indexers to provide these indexing services? So we did some research into how large the chains are for the networks are for each chain, and this, to the best of my knowledge, is accurate as of about a month ago. So some of these may have changed. However, kind of like looking at these numbers, we can see that the model that we are proposing has this relationship between the storage required to run a chain and the amount of RAM that's necessary to run the archive node. So, for example, in 𝗨𝗀𝗀𝗃𝗀𝗀's case, we have this 22 terabyte behemoth that needs 128 gigabytes of RAM, and that's because.
Hey Samuel, sorry to interrupt, but just so people can see it, Matthew said it's a bit small. He can't see the numbers. Is there any way that you can zoom in or enlarge those numbers?
I mean, I'm kind of full screen at the moment, so I'm not sure if I can.
Okay.
I can provide these slides later for people if they kind of want to check them out afterwards, if that helps.
Yeah, that'll be amazing. Yeah, sorry to interrupt. Amazing.
Okay, cool. Yeah, hopefully as many people can see. But yeah, I guess we'll provide the slides. So yeah, one of the assumptions that we made is there's this relationship between terabytes of storage and gigabytes of RAM. So this model assumes that for each 22 terabytes of storage, an archive node needs 128 gigabytes of RAM. And it also makes an assumption about a relationship between terabytes of storage and threads of CPU compute. And that ratio being for each 22 terabytes of storage, you have 20 thread requirement. So, for example, you can see here, just like Avalanche, it had 10 terabytes of storage required. So we're almost half of this 128 gigabytes of RAM, and almost half of, well, actually, in this case, it is half, but that's because there's some rounding. But yeah, half of 20 threads. So going back to this initial question, how much will we pay indexers? Well, so we had the prices here that we researched, and the numbers that we've settled on at this point in time is we would pay $25 per terabyte of storage per month, and 75 cents per gigabyte of RAM per month, and $10 per thread per month. And when you compute this together, you have a storage cost. This is for 𝗨𝗀𝗀𝗃𝗀𝗀 again, just as a point of comparison. We can see the bulk of this payment is essentially for the storage costs, $550 here. This says $96 per month and $200 for the cost of compute. And so the total of this for 𝗨𝗀𝗀𝗃𝗀𝗀, we think it costs indexers $846 to run this archive node per month. And what we've decided that the gateway will seek to cover 50% of this cost, because indexers are already earning GRT from indexing rewards that they can use to offset the other 50% of the costs. So in this case, we would seek to cover the $423 there. No, I'll just go on to the next slide. So I haven't yet explained how many subgraphs you would be needing to index to get this $423. So we'll get on to that. So first of all, let's look at this table. So it's a table showing the percentage of subgraphs that have more than a certain query volume over the last 90 days. And we can see from this, hopefully people can read these numbers, that there's 97% of subgraphs got over 100 queries over the last 90 days. And then going down the list, we can see that only 24.71% of subgraphs had more than 1 million queries over a 90-day period. So I think that data consumers will pay for dips on subgraphs that have more than a threshold amount in this range. And the amount that I'm proposing for now is it's going to be somewhere in the range of about 5,000 queries. That's where someone would find enough value from querying a subgraph where you're likely to pay for it to continue to be indexed via dips. So with that assumption in mind, then we can see these networks here, for example, mainnet. In total, there was 1,700 subgraphs on mainnet, but with this 5,000 queries per 90 days sort of applied to that, then we had 1,034 subgraphs that got over this threshold. And we can see that each subgraph turns into 3 indexing agreements for indexers to compete for. So that this actually turns out to be 3,100 indexing agreements on mainnet. Yeah, you can kind of see it in the chart how many indexing agreements we have for each chain, and there's a sum here that is to say that we expect, or we're anticipating there being somewhere in the range of 12 to 13,000 indexing agreements to compete for. And here we can also see there's a chart showing the number of allocations that indexers have made. So just to read this out, we see that there's 44 indexers on the network that have more than 20 subgraph allocations. And there's 33 that have more than 50, or 11 that have more than 250. And we had some initial conversations with indexers, and we're asking them about how they are scaling and how difficult it is to scale. And some of the feedback that we got was that scaling from 50 allocations to 250 was approximately as difficult as scaling from 10 to 50, which was quite interesting. But I guess the rationale behind that was once you get to this kind of 50 level, scaling beyond that is easier because you have kind of tools and automations in place, and you're more familiar with the process. But obviously it can be very difficult to scale to the far right side of this graph. So I don't want to underplay that it is difficult. It certainly is, and it is a competitive market. So yeah, we'll move on to the next slide. So here we can see that there's a data frame showing basically the same chart as before, but in table format and broken out into each network. So here that we can see that there's 32 indexers that have more than 20 allocations on mainnet. There's 29 indexers that have more than 20 allocations on Arbitrum, and so on and so forth. And one of the things that I want to point out is if we make an assumption here that some proportion of indexers will not be set up to accept and start competing for indexing agreements on each chain, then I think it makes sense to look at how many indexers are actually likely to be accepting and competing for indexing agreements. Because I don't think it's the case that indexers that only have, for example, 1 to 4 or even 10 indexing agreements on chains are likely to be competing as much as some of the indexers that may have, for example, 250 existing allocations across all of the chains that they support. So I'll go to the next slide. So yeah, here we can see again the number of indexers on each network that have at least 20 subgraphs that they're allocated to, and the anticipated number of indexing agreements that we could expect to see created on each chain. And in this column here, it says average DIPS agreements per active indexer on the network. So it's just simply done by dividing the number of indexing agreements by the number of active indexers on the network. And so this is kind of like a great average that can show us how competitive the market is for each network. And then with that in mind, we also have the archive node cost. So that this was something we introduced in one of the prior slides. And given this cost and the number of indexers, number of indexing agreements that we expect indexers to receive on average, then this would really need to be the payment that an indexer gets to justify their work. However, as we said before, about paying 50% of this amount because of indexing rewards covering a large percentage of indexers existing work. So yeah, it would be 50% of this amount per subgraph that an indexer seeks to support. So as an example, if you had 100 indexing agreements on mainnet, then you'd be earning $200 per month or 2,400 per year. Well, 50% of this amount, and as an example as well, if you manage to get 400 indexing agreements, then that would climb to 800 a month or 9,600 per year. But again, 50%, and this would just be for that specific network. So obviously, you could scale to support many more networks. A note here that not everyone will be able to secure 400 indexing agreements, as we do anticipate subgraph indexing to be a competitive market, and the IASA will be tuned to reward the best indexers with the most indexing agreements, and factors that indexers can start to think about to improve their chance of being selected by the IASA. They can increase uptime, query success rate, query response latency, so decreasing the response latency, and competitively pricing the indexing services. Yeah, and these are all things that would contribute to having a higher overall weighted score and being selected to receive more indexing agreements. Okay. So here we're looking at the distribution of entity sizes across various subgraphs. So on the x-axis, we're looking at the kilobytes per entity as a log scale, and on the y-axis we have cumulative distribution as the blue line and probability density as the red line. So we can see here that from this grey dotted line, there's a 75% chance that a given subgraph, if you were randomly chosen to index a subgraph, there's a 75% chance that subgraph would have an entity size that is less than 2 kilobytes. There's a 95% chance that it would have an entity size that is less than 33.2 kilobytes. And there's a 99% chance that the entity size on average would be less than 143 kilobytes. So this is obviously a dramatic range, and it does show that there is a long tail of subgraphs that where the entity size is significantly larger than the mean. So the true average entity size, when you look across all of the subgraphs and take into account all of the entities, is 0.72 kilobytes per entity. However, the average of averages subgraph entity size is actually 8 kilobytes. And I have a note here which I'll read. When you calculate the entity size using an average of averages approach, each subgraph's average entity gets the same weight, even if that subgraph only has a handful of entities. This can give outliers, like a singular subgraph with a very large entity, a large impact on the final outcome. So one subgraph that has one entity that is 1 gigabyte in size, as an example, if this subgraph were to exist, and another subgraph that had 1 million entities, where each entity is 1 kilobyte in size, then if you took an average of averages approach, then you might think that each entity is actually 0.5 gigabytes. While if you computed a true average across the 1,000,001 entities, then you'd say that each entity is 2 kilobytes per entity. So yeah, the implications for indexes are you could get unlucky and index a subgraph where or receive an indexing agreement on a subgraph where that subgraph has a very large entities, but as you accept more indexing agreements, the outliers will start to matter less and less, and your overall entities for the entities that on the subgraphs that you're indexing, they will converge and they'll trend towards this true average. So yeah, if you have this single subgraph focus, then you're like the average is more in this 8 kilobyte range. But as you scale and accept more indexing agreements, then you'll be looking at this true average. Something else to note here is with this true average of 0.72 kilobytes per entity, if you were storing 1 billion entities, for example, then you would expect 1 billion entities to take up 686 gigabytes of space on your drives. And with the payment that we discussed earlier, the $25 per terabyte per month, then the payment for the storage of these 1 billion entities would be $16.76 per month. So yeah, and now we're gonna look at the pricing model. So for the ongoing sync, we have a base payment, which seeks to cover the cost of the archive node, and we have, and this is paid per epoch, and then we also have this one varies per chain. So for Arbitrum, for example, it will be higher, and on mainnet, for example, it will be lower, because Arbitrum has a larger chain size. And then I see I'm misspelling here, but then we also have the entity base payment for the chain, and this is multiplied by the number of entities for the subgraphs that you're syncing, and this is paid out per epoch. So we'll see how this compares to a V2 pricing model later on. But for now, this is the plans for the V1. So here we can see the number of entities on each network. So for example, we're looking at base, and it has 15 billion entities across all of the subgraphs on this network. And if you wanted to store all of these subgraphs, then you'd be looking at approximately 9.2 terabytes of storage. And you can also see the average entity size on base is around 0.64, so slightly lower than the average, the true average across all the networks. And this takes into account approximately 19% of the data that we have. Yeah, you can kind of see as we go down the rows in this table, how the estimated average entity size changes. And as we get towards the bottom, it becomes more variable, and we'll see this in a chart on the next slide. Whereas near the top, it's a bit more tight of a range, and it's more controlled and closer to that true average of 0.72 kilobytes per entity. So I just made a note here to say that in a future V2 version of the pricing model, we're planning for indexers to be able to provide the sum of the bytes of the entities of each subgraph that they have indexing agreements for, and then they would be paid proportionally to that number of bytes. However, in V1, indexers will instead provide the sum of the number of entities. So not the sum of the bytes, but the sum of the number for each subgraph that they have indexing agreements on, and then they are paid proportionally to that number of entities instead of the size of the entities themselves. So this is, for V1, this is slightly more lossy of a proxy for the true size of the subgraphs, but with V2, then it should be a more accurate proxy. So yeah, in the V2 model, we'll be seeking to eliminate the chain-to-chain size variance, and subgraph to subgraph size of entity variance. So there'll be no risk in accepting indexing agreements on subgraphs that have large entities relative to the mean, as you'd just be paid relative to the size of the entity, not to the number of entities. So yeah, looking at this chart here, we can see a bit more visually how the size of entities changes across various networks. Again, you can see that the range is relatively more tight for the network mean as we start out, and this is really great to see. These chains here represent 98% of the data that we had available from the upgrade indexer. And then as we looked further towards this kind of long tail of networks that subgraph developers are not building on as much as these ones, we can see that the variance does start to increase, and especially towards this tail end of the chart. But again, something to note is that there are outliers, and with a singular subgraph focus, it could be the case that with a V1 approach that you could get sort of unlucky and have to index a subgraph that has a extremely or just very large entities. But as you accept more indexing agreements, then your entity size will converge to the true mean for each network. So how do we plan to evolve the indexer payment pricing model over time? So we've already seen this slide, so this is just a recap. We had this chain-based payment component and the number of epochs, and multiplied by the number of epochs, that is, plus the entity-based payment component per epoch, multiplied by the number of entities, multiplied by the number of epochs here. And then for the V2 pricing model, you can see it's substantially changed from V1. So first covering the ongoing sync component here. The ongoing sync component, the first part of it at least is the same. So you still will be paid the chain-based payment per epoch, and then multiplied by the number of epochs. And then you will also receive a gas-based payment multiplied by the subgraph gas and the number of epochs still. So this gas-based payment is seeking to pay indexers appropriately for the amount of work that it takes to continue to stay at chainhead between POI submissions on a specific subgraph. So, for example, one subgraph that has a lot of computational requirements to stay at chainhead, in general could cost an indexer more money to stay at chainhead than another subgraph that doesn't have as much processing requirements. So that's what this subgraph gas component is seeking to pay indexers for, and that's one of the larger changes between the V1 and the V2 model. And then we also have a slight change here. So we discussed this previously, but the entity bytes. So if I just go back to the prior slide, we had this entity-based payment. So you were being paid proportionally to the number of entities. But now here in the V2 model, or at least when the V2 model goes live, then an indexer would be paid proportionally to the size of the entities rather than the number of entities. So that this should be a much more accurate way to be paid. That decreases that subgraph to subgraph entity size variance. And then just kind of addressing the payment for the initial sync, it's essentially the same as the payment for the ongoing sync. The only big difference here for the V2 model is that the initial sync would actually be paid in a linear vesting contract. That's the current plan over 4 to 6 months, not 46, but 4 to 6. And that would be claimable whenever for tax efficiency. So one of the reasons that we've chosen to pay this initial sync over a longer duration rather than paying it initially or having it being claimed whenever an indexer chooses to claim is just to further incentivize indexers to uphold let's say longer term commitments when they accept indexing agreements. So if an indexer was to accept an indexing agreement, sync to chainhead, and then immediately drop the support for the subgraph, then they would essentially forfeit the remaining of their initial sync payment. They would only be able to claim up to the point where they did their final POI. So now we'll just look at the initial batch of networks. I see we have 5 minutes left, so I'll try to be quick. At this point in time, we've decided that DIPS will go live with these 7 networks. So just to read these out, that we have mainnet, Arbitrum, Matic, Binance Smart Chain, Base, Avalanche, and Optimism. And then we also have some rationale for why these 7 networks have been chosen and why not others. Obviously, in the future, DIPS will roll out to more networks. So this is by no means a final. Sorry, by no means a final version. But for example, for the reasons why these 7 were chosen, so we have here support. We can see that support from the graphed networks of indexers were generally highest for these 7 networks. So if we look here at this table, we can see that on mainnet, for example, there were 32 indexers that had at least 20 allocations. And looking down the list for these 7, we can see that all 7 of them have at least 10 indexers that support 20 that are allocated to 20 subgraphs. So that was really great to see for these networks. And we can also see in this table here that there's at least 2 billion entities across all of the subgraphs for these networks. So for example, we had Avalanche that came in at 2 billion entities. And then we also have ZK Sync and Celo, which are not part of these 7. But that was mainly because they sort of didn't hit the mark at this point in time in some of the other metrics that we're looking at. But then Optimism had 3.8 billion entities and so on and so forth as we look up the list. And then one of the final things to note here is we're also anticipating that these networks could all have more than 500 indexing agreements that indexers can compete for. So, for example, again, just reading bottom to top, Avalanche had an anticipated number of indexing agreements of 714, and then going up to Optimism 720, and then pretty soon we get into this 1,000 range. So it was just really great to see that was the case for these 7. So that's kind of why they were chosen. So how much will our gateway initially charge subgraph developers for subgraph indexing services? So this is again looking at the subgraph developer side rather than the indexer side, and how do we plan to adjust this pricing over time? So just to give clarity on this, for indexers, we'll be paying using the pricing model previously explained, paying those indexers using that model. But for subgraph consumers, we plan to have a far simpler model where they can pay for services as per the following. So here we can see, if you can imagine you're a subgraph developer and you have a subgraph that you want to be indexed, you would be looking at paying initially. So obviously this pricing is subject to change, and we do anticipate it changing over time. The base price, so this is how much you would need to pay to have your subgraph indexed. You would be paying $10 per month. These are all monthly payments. And then you would also have an initial tier. So this covers you from 0 to 10 million entities. So the initial tier, you would pay $15 per million entities per month. And then if the subgraph had more than 10 million entities, you would sort of break into this higher volume tier, and you would pay $7.50 per million entities per month for any entities included into this tier. So for example, if the subgraph had in total 25 million entities, then the first 10 million entities, you'd be paying $15 per million per month. And then for the next 15 million, we said 25 million, the next 15 million, you'd be paying $7.50 per million per month. And then this price reduces as you get into these higher volume tiers, and you can see for the highest volume tier, it reduces down to $1.50 per million entities per month. So I also have a table here showing some example subgraphs. So for example, if your subgraph had 150 million entities, you'd have to pay the base price of $10 base. You'd pay $15 per million entities for each of the 10 million entities in the initial tier. So you'd be paying 150 million in this tier, and I guess so on and so forth. And the sum of these, so the monthly cost for subgraph indexing for this 150 million entity subgraph would be $722.50 per month. But this really is a very large subgraph with 150 million entities, and you can see for perhaps a more reasonably sized subgraph in terms of entities count, with 1 million entities, then your monthly subgraph indexing cost would just be the $25, which was made up of a $10 base price plus a $15 from the initial tier. So I also have an example here which compares the cost against a fixed price of $25 per million entities per month. And this is just a comparison, and we can kind of see the savings here by adopting this model instead of a fixed model that could charge $25 per million entities. So for the large subgraph here with 150 million entities, as per this model, just as a comparison point, you'd be saving 3,000 per month, and so on and so forth for the other subgraphs. So how do we plan to adjust this pricing over time? That's the next question. For the base price, we're considering and evaluating whether we can completely eliminate this base price, which would be great to see. I am reasonably confident that that's something that we could do. For the initial tier, we think we can introduce a variable pricing per network. So, for example, when we looked at the size of chains on some of the other networks, some of the largest networks, Arbitrum was 22 terabytes. So you could expect this initial tier to be slightly higher there. But then comparing that to mainnet Ethereum, you could expect this initial tier to be lower because that chain is smaller. So that would be kind of the plan, and something that we'd be proposing. It would be to introduce this variable pricing. And then for each of these three tiers following that, we think we can reduce these numbers and make this even more competitive for subgraph developers. And we may also be able to combine these three tiers into one to simplify things. So essentially you'd only have a base price, an initial tier, and then a high volume tier, and then the pro and the max would essentially be deleted. And the high volume tier could potentially in the future start at the price that the max volume tier is sort of leaving off from. So I think that's something that we can aspire for, and can make DIPS even more competitive than it's already planned to be. So that's kind of the goal there. Hopefully we have time for some questions. Maybe Abel can let us know how much time we have left. I see it's 4 minutes past at the minute. Has anyone got any questions?
Yes, people do, and Pablo's been doing a fantastic job of answering them as they've been coming through, but you've got a couple more here. Any ones that haven't been answered so far, just feel free to repost and we'll get them addressed. But two new ones have come in. First is from Chris for Pablo, saying when... Oh, that was a joke. Okay, cool. Thanks for clarifying. And then Vince is asking, is the curation market erased in DIPS era? If so, how do we communicate? How do we communicate to release their liquidity in a graceful way?
So yeah, the plan is not to just erase the curation market. We think the curation can live alongside DIPS, and it's likely the case that if I just go back to this slide here, for subgraphs that are extremely large, we do think data consumers subgraph developers will actually use curation instead of dips to have their subgraphs indexed, because it can be more cost effective for them to use curation instead of paying via dips. And that's not really a knock against dips. It's sort of just a nod to curation. That is a service that's available for some of the largest subgraphs. So yeah.
Fantastic. Hopefully that answers your question, Vince. A few people are typing, so we'll let the questions roll through. Do you have access to the chat, Samuel, or would you like me to read the questions out?
I do have access to the chat. Yeah.
Cool. Awesome. What I've done is I've labeled the question, so it looks like there's one from Chris there.
Okay, so the question is, I understand that ENN is also engaged in curation. Yep. How is ENN thinking about the value of dollars deployed across these two mechanisms when we do one versus the other? I'm probably not the best person to answer that question. I don't know if anyone else from ENN would like to take that.
Hello, can you clarify the question, please? I'm not sure I understand. Thinking about the value of.
Can you hear me? Hello?
I certainly can.
You?
Yeah.
Perfect. Okay. Sorry, new computer, just checking. Pablo, what I mean is that I guess from Edge and Node's perspective, there's a certain set of customer expectations with respect to the quality of service delivered. And you kind of have two means to an end to accomplish, that QoS via external index, both involving incentives, right? Dips and curation. So in different scenarios, each mechanism will be more or less effective and kind of represent a different return on investment in terms of achieving that QoS for the consumer.
Yeah. Well, I mean, that's something that I would say we're still investigating from a product management perspective, and James is not here, but he's doing kind of the more like product oriented aspect of this, of like trying to figure out what's the best way to show these new interfaces to consumers. So I'd say that's an evolving conversation. What I would say is, from a more pragmatic point of view, we do want to try to reduce the network's reliance on issuance as much as possible. So the more people using dips that we can get, I think, the better, because that means someone's actually paying for the value that they get from the network versus locking capital and kind of getting some value through that issuance, right? That it's sort of the whole protocol paying for it. And I think a lot of that will change as well as JP70 is rolled out, and then maybe like the way that issuance is distributed might change. There might be other avenues for issuance to flow as well. So I'd say that's going to be an evolving thing. Generally, if you ask me, not Edge and Node, I would say I would prefer if more people move to dips versus curation. I think the UX of dips is going to be much nicer in that like you can just pay and get stuff indexed versus having to do kind of the whole locking capital thing. But yeah, I'm not sure if that's it's not a very concrete answer, I know, but it's not something that we have thought out to a lot of detail at this point. Or how we decide to do one versus the other. I think we would generally like, the way we're thinking about it right now is the developer pays based on these prices, and then we just pay dips. If it turns out that it's a lot more efficient to do curation versus dips in some cases, then I guess we would consider it. But for now, we're assuming we're just doing dips as a way to pay indexers for the indexing. And then curation happens like in parallel.
Yeah, and I also see Enson comments. What is the threshold between dips versus curation being more cost effective? I think that probably depends on someone's personal view to if perhaps if they already have GRT, then curation can just be more cost effective from the outset. But if they're thinking about purchasing GRT, then it can depend on the price of GRT, of course, and also the sort of exposure to the price volatility in GRT. Um, but I think somewhere in the range of kind of between about $50 to $100 per month. After that point, it does become more appealing for someone to instead of using dips, if they understand how curation works, then perhaps that they might prefer to curate on a subgraph instead. That's not going to be the case for everyone. Some people would just prefer dips for various reasons, but it could be the case that people will like to use curation beyond that point.
One question about any sort of like gamification or edge case type stuff where this could be exploited. Have you thought through, the idea of indexers that are maybe running multiple indexers off one Postgres instance or something like that, where, I don't know, I'm just thinking out loud here, but ways that they can, I don't know, claim more than they really should be able to based on their on the infrastructure modeling, that type of thing.
Yeah, it's an interesting point. Definitely, we do want to prevent those kinds of Sybil attacks, where an indexer could try to get more indexing agreements than than another indexer who isn't Sybiling the network. And one of the ways that we're thinking about addressing that is introducing this notion of stake to fees. So the number of indexing agreements that you can receive from the ISA, one of the components that will enable you to be selected is how much stake you have relative to the fees that you're collecting on chain. So if you do have, if you've split up your indexer into many smaller indexers, then obviously you're not going to be able to deploy the same amount of stake across each one as you would inside one singular large indexer. So that's one of the ways that we are hoping to combat that.
Right, so that's something down the line then. This isn't something.
I mean, that will be part of the ISA.
Oh, okay.
Yeah. It's not a perfect solution still, because it's not like it's directly proportional, which would be the one solution that is like truly Sybil resistant. But there is another aspect that is in the ISA, and this is more like for a future implementation. You could check the correlation in the downtime across indexers and kind of deprioritize indexers where you see like a very strong correlation in the downtime. Especially when you're asking to index the same subgraph, that is where a Sybil would be more damaging. You can check that the three indexers that you choose for a subgraph are indexers where their downtime is as uncorrelated as possible, and that helps like in a different dimension as well.
Also, another thing to note: once Dips is live, we can continue to iterate on it and kind of like speed up the release cadence for future upgrades and versions of it. So yeah, it's just getting to the point where it's live is one thing, but then iterating from there should kind of we could anticipate that to be a bit faster going forward.
Do you expect to ratify your modeling, as in both directions, right? So Arbitrum nodes, archive nodes are growing at 1 terabyte a month. Polygon moving from Aragon 2 to Aragon 3, so your storage footprint is, I think, halved. Any thoughts on like the sort of live modeling that's required to kind of keep the models accurate based against the technology?
Yeah, so at the minute, we've just asked indexers to kind of self-report the size of the chains and verified that as best as we can. Going forward, it does make sense to have a more dynamic model where we can just get those sizes a bit more trustlessly than sort of saying to indexers, hey, how big is Arbitrum this month? So yeah, that is something that we would love to do and implement.
Okay, I see a few people typing, so I'll just give it a bit more time. Great, Matthew, adding some additional context. Thank you. As people are typing, I would recommend grabbing the 200th POAP of 𝗨𝗀, which is a special one. Hope you guys enjoy that. Okay. Oh, people seem to have stopped typing. Okay. Well, if anyone has any burning questions or thoughts, please do type away. We'll try to get that squared off. If not, then could you do me a favor, Samuel, and just pop the link of the presentation in the chat so folks have it? That would be fantastic. Otherwise, you can always send to me, and I'll send it out to people later, or tweet it out, or put it in the link in the description, whatever's easiest. But ideally, if we can get it to them now, that'd be great. And if there aren't any, oops, sorry, go ahead.
Yeah, and what I'll do is I'll probably send it to you a little bit after we end this call, just because I'm going to move it to a new slides, and then we can send that one out. So that will probably take a couple of minutes, but yeah.
Yeah, of course, no problem. So I'll just tweet it out and put it in the recording description of the YouTube video so people have access to it. Okay, great. Well, we've got another comment here from Pablo. Oh, yeah, sure. Go ahead. What's up, Vince?
Oh, sorry. I was just going to say also similar to what Jim said with the ratification and stuff. I think it would also be wise to, I know we've talked about the registry, the chain registry and everything, but also maybe I don't know, a cost registry or some type of what you're going to be reimbursed for running X chains, so indexers can make, decisions for themselves transparently about, like, I'm going to support this chain and this chain because it's paying this and it's paying this, so we can make decisions on kind of like what services we offer, basically.
That's a great idea, having like a public place where we show the, yeah. It's worth noting that like these prices are going to be like initial budgets that we set from the Agent Node Gateway. Eventually, indexers can set their own prices. So this is kind of the reference pricing that we're going to start with. The first version will not have kind of pricing as part of the ISA, but the hope is that like eventually the gateway might have a budget for what's the maximum that we're willing to pay for each subgraph on the chain. But it should be, I think, up to indexers to decide, okay, what is the actual price that they want to charge on something. So there's actually a competition on the pricing as well. I don't think there's a way we can avoid that and still have a competitive product as the graph as a whole going forward.
Yeah, especially with decentralized gateways and stuff, like Chris is saying, some of those problems are solved, and being able to see like, oh, there's like 10 gateways. This gateway is paying X amount for Polygon. This gateway is paying this for Polygon. And you can kind of make decisions on that.
Right. Well, also, as soon as the smart contracts for this are ready, you will be able to see all of the agreements that are happening on chain. So you should be able to build a subgraph that just extracts the latest prices.
Got another question there from Josh.
Not yet, but that's a good idea. I mean, the tricky thing there is like indexers are doing very varied things. Like it depends on which chains, how many subgraphs you actually get, how much you're actually allocating. It's a bit tricky to model, I think, in a general way.
Well, I think if you just pick
We could
three indexers at random and just assume that everything they're currently doing, there's no assumptions made. It's just these are the subgraphs, and then you can find all the entity counts and all that. Take your pricing that you've computed.
Yeah.
Yeah, I think we can look into that. My guess is that it will be there'll be quite a large variance depending on which three get randomly selected. Like, for example, if you pick one that has extremely large GRT stake, then the indexing rewards for that are likely to be pretty high relative to potential dips earnings. But then if you have one of the perhaps smaller indexes that doesn't get as much in indexing rewards, then it's probably going to be a lot more significant for them with the addition of dips payments. But yeah, certainly we can take a look.
Seems like there's some back and forth there in relation to the stuff that Chris and Pablo. But feel free to hop on the mic if that's easier.
It might be worth having a separate discussion for that because it's a long one, and maybe having Rem there, because I do think it solves the free riding problem. Like for context, in 𝗨𝗂𝗪 there is a sponsor role that is basically someone paying dips and agreeing with the indexer for a fee cut. So if I pay dips on a subgraph as a gateway, and then another gateway queries from that same subgraph, whoever paid that dips agreement is going to get a cut of those like external query fees. So the idea is it solves the free riding problem because whoever is paying for the query fees is going to be paying for that indexing cost that the sponsor originally paid. It depends obviously on the size of the cut, but that's why in Rem's proposal, gateways and indexers kind of negotiate that cut. I'm not sure if it solves it. Yeah, it tries to solve it at least.
Luckily, we've got Rem joining us next week for a further discussion on protocol economics. So, yeah, I guess tune in to that. But then also, yeah, if you guys want to take that offline, feel free to. Okay, well, we are, wow, this is probably one of the longer episodes of IOH, which is fantastic. I guess it's episode 200 and it's a special one. So, yeah, thanks for staying, everyone, as Chris is saying, and walking through this conversation. Yeah, thanks for preparing all this information. Yes, thank you to all of the Edge folks, particularly you, Samuel, and also you, Pablo, for helping out here. It seems like this was very informative and a lot of research was done, as Matthew was saying, which is fantastic. And yeah, it looks like a ton of work went into putting all of this together. Thanks for the hard work and effort, guys. Thank you. Yeah, you're getting a lot of positive comments in the chat there from the indexes, which is always great to see. And there you have it. That was number 200, episode number 200. That's incredible. I can't believe we've been here almost every single week now for the past 2 to 3 years, shipping out these IOH episodes. This is incredible. Very much grateful to everyone who joins us every single week. I want to hand over to maybe Pablo and Samuel for some final thoughts, seeing as you guys put a lot of effort into this. Maybe you guys want to share a few things before we wrap.
Nothing in particular from me, but I mean, thank you everyone for joining in, and yeah, it's great to sort of be here for the 200th episode. That sort of happened by chance. So yeah, thank you everyone.
Amazing.
It was Samuel's research here, so kudos to him for doing this, and thank you all for having us.
Thank you, Samuel, and thank you, Pablo. You guys are the best. We do appreciate you, and thank you everyone for joining for today's episode of IOH. And we look forward to seeing you next week for a protocol economics discussion with Rem. Take care, everyone. Have a wonderful rest of your week, and on we move to episode 201. Take care, everyone. Bye-bye.